Hello students, welcome to advanced classes. Let's do Algebra Fundamental Concepts, Chapter 13. Question 1. Separate constant terms and variable terms from the following. So we have a list of terms. We need to pick out the constant terms from these and the variable terms from these. So what are constants? All the digits that we use in arithmetic from 0 to 9 and all the numbers formed by these digits, they all have a fixed value. So they are said to be constant. So they are the constant terms. So all numbers are constant terms. In algebra, we use letters of the English alphabet and they can take on different values. So they are called variables. A variable can be just a letter or it can be a combination of a constant and a letter, a number and a letter. Now let's look out for only the constant terms. Look out for numbers that are fixed, that have a fixed value. So let's start with the first one, 8. 8 is by itself, so it's a constant. X is a letter which can take on any value. So it's a variable. 6xy, a combination of a constant and a variable, is always a variable. 6 plus x is a variable. Whenever you have a letter, it is a variable. Then we have the next one, minus 5xy square. It's a variable. 15az square is a variable. 32z by xy, variable again. Y square by 3x is a variable. So we only have one constant term here. And the rest of it, they are all variables. Question 2. For each expression given below, you have to state whether it's a monomial, binomial or trinomial. They're all polynomials. What are polynomials? They have one or more than one terms separated by the plus or minus signs. Now, let's look at the first question here. Now, if you take 2x divided by 15, they are not separated by a plus or a minus sign. Instead, it is separated by a division sign. That means I can put this as 2x by 15. I can write this as 2x by 15. That means it has only one term. So now it has become 1. It's become a single term. So if there is only one term, we call it a monomial. Question 2. I can see two terms here separated by a plus sign. That means I cannot make them 1. So we have two terms here. Therefore, it is a binomial. Here I have 3x squared separated by a multiplication sign. That means I can work this out to make it a single term. I can make it a single term. I can multiply the numbers first. 3 5s are 15. And I can multiply my variable. There are 2 there and 1 here. It becomes 15x to the power of 3. So now that has become one term. Therefore, it is a monomial. Question 4. 5 plus 2a minus 3b. Okay, let me see if I can combine anything to make it a single term. I cannot because there are plus and minus signs. So let's count the terms. 1, 2a is another one, 3b is another one. So there are 3 terms. Therefore, it is a trinomial. Question 5. We have one term, 2y minus 7 by 3z divided by x. Divided by x. That means if I have a division sign or a multiplication sign, I can combine it to make it one term. So 2y minus the second part. So this is how I get it. Therefore, there are only 2 terms and it is a binomial. So you don't have 3 terms there. There are only 2 terms and it is a binomial. Question 6. 3p into q divided by z. There are no plus and minus signs. That means I can put all these together to make it one term. So this is what it will look like. 3p into q becomes 3pq divided by z. Therefore, it is a monomial. Question 7. 12z divided by 5x. Now this becomes one term because there is a division sign there, plus 4. So we have two terms, 12z by 5x plus 4. Therefore, it is a binomial. Question 8. 12 minus 5z minus 4. Question 8. Now here I don't have a multiplication or a division sign. I cannot combine any of these terms. So they're all separate. I have 1, 2 and 3 terms. So it is a trinomial. Ninth one. I have a cube minus 3ab square into c. So since I have a multiplication sign, I can convert this to one term. It becomes a cubed minus 3ab squared c. That means there are two terms and it is a binomial. Okay, moving on to question 3. Coefficient. Write the coefficient of, in the first one, xy in minus 3axy. Okay, what is a coefficient? Any factor or group of factors of a term is called the coefficient. Now I have xy. Now let me keep only xy here and look at the remaining. Now I have minus 3a. So if I leave out xy, the coefficient of xy is minus 3a. The second one, I have z square. Let me remove z square. The remaining will be my coefficient p square y. Question 3, I have mn. Let me remove mn. Now I only have minus, but I have 1 there. There is 1 mn and here also I have 1 mn. So it becomes minus 1. 15 in minus 15 p square. So I'm going to take off the 15 from here. What is left is minus p square. Okay, now we move on to degree. Write the degree of the following monomials. Now what is degree? Degree of a monomial is the exponent of its variable. Okay, that is the power of the variable or the sum of the powers. Now here we're going to look at the degree. That means we're going to look at the variable, which is y, and its exponent. Exponent means the power. Now how many y's do you have here? Only one. The power is just 1. So my answer is 1. The degree of this monomial is 1. Now here I have 2 and then I have 1y. So the degree is 2 plus 1, 3. Okay, let's count the powers. 1x, 2y, 1z. So now totally we have 1 plus 2 plus 1, which is 4. The degree of that polynomial is 4. Moving on to question 4. Let's count. The power here is 2 plus 3, which is 5. So that's how we write the degree of monomials. Question 5. 3 plus 4 is 7. So I'm counting the powers. That's 7. Question 6. P, Q and R have powers. So 2 plus 3 is 5. 5 plus 4 is 9. Okay, now we're going to look at writing the degree of polynomials. So here we have different terms. So here it is, the degree is 3. Here the degree will be 2 plus 2, which is 4. And here the degree will be 1. For a polynomial, you take the highest degree. So which is the highest degree here? 4 is the highest degree, and that will be my answer. So the degree of this polynomial is 4. Let's count here. 3 plus 2 is 5. 5 plus 2 is 7. 4 plus 4 is 8. So I'm counting all the powers and I'm looking at the highest power, which is 8. So the degree of that polynomial is 8. Let's count here. Here I have 1m and then 6. So 1 plus 6 is 7. 3 plus 1 is 4. And which is the highest power here? 7. So the degree of this polynomial is 7. Next one. Here I have 2 plus 1, which is 3. And here I have 2, which is the highest degree here. The highest power is 3. So the degree of this polynomial is 3. Look out for the highest power. Next one. Here I just have 1. Therefore, the degree of that polynomial is 1. Next one. 2 plus 1 is 3. 3 plus 1 is 4. So the highest power here is 4. So the degree of this polynomial is 4. Group the like terms together. Terms having the same literal coefficient. What does that mean? Terms having the same alphabetical letters are called like terms. So let's see which are the ones. So we are not looking at the numbers, we are looking at the letters, the variables. Here we have x square. Okay, so let's look and see if there's any other x square. Okay, here I have another x square, one more x square. So these three are like terms. One set of like terms. So let's write that down. 9x square is 1, minus 3x square and x square are like terms because they all have the same letter. Can you see? They all have x raised to the power of 2. Now what about the next one? xy and minus 2xy are another group of like terms. So I have xy and minus 2xy. So there are two sets of like terms. This is the first set and this is the second set of like terms. Now going on to question 2. Let's see. AB. Let's look out for AB. We have minus 3AB. Keep looking out. That's it. We don't have any more AB. Okay. Now look at the second one. It's minus A square B. That means there are two A's there. A square B. Let's see if we have A square B. Yes, 5 A square B. And we have minus 8 A square B. So we have two groups of like terms. So the first group, let's write it down. AB and minus 3AB. They are like terms. Can you see both the terms have A, B in them? The second set of like terms, minus A square B, 5A square B and minus 8A square B. They all have A square B in them. A square B, A square B. Let's go on to question 3. Now here I have P. Let's look out for other terms that have only P. Not the second one, not the third one, the fourth one. Yes, minus 2P and the last one. Then let's see the ones not underlined. 8PQ. Okay, this is PQ. Now, is there another term with PQ? Yes. minus 5pq. Let's write down the first set of like terms. 7p minus 2p and 3p. Moving on to question 3. Let's look at the like terms here. Now we have p, the letter p. Let's look for more with this. Okay, so 7p, and then we have minus 2p and 3p. So we have the first set of like terms. Then we have 8pq and minus 5pq. So let's write down the first set of like terms. 7p minus 2p and 3p. That is the first set of like terms. The second set of like terms, 8pq and minus 5pq. Now we move on to the numerical coefficient. If the factor is a number, then it is called a numerical coefficient. If the factor is a letter, it's called a literal coefficient. Okay. So if the factor is a number, now here y, there is one y, isn't it? So what is the number here? 1. So the numerical coefficient of y is 1. Here there is minus 1y. So the numerical coefficient is minus 1. Here the numerical coefficient is 2. Pick only the numbers. Pick out only the number. Minus 8 is the numerical coefficient. 3 is the numerical coefficient. Minus 9 is the numerical coefficient. So pick out only the number. So here we have one term. Write the coefficient of these that are given here. Only z square. That means I remove z square and I write the rest of it. Okay. Now let me write the rest of it. That becomes minus 5x cube y square and z. There is 4. I'm going to take off 2. So I have the remaining 2. Z or z to the power of 2. Write the coefficient of y square. So leave out y square and write the rest. Minus 5x cubed z 4. Okay, now we'll go on to the next one. That is yz square. So I'm going to take off 1y and I'm going to take off 2z. So let's write the remaining. Minus 5x to the power of 3. Y, there's only 1. I need not write y to the power of 1. And z, I'm going to remove 2. So it becomes 2. Okay. Then we go on to the next one. I'm going to take out x to the power of 3 and 1y. So I'm going to remove the whole of x to the power of 3 and 1y and write the remaining. Minus 5. I've removed the whole of x to the power of 3 and I've removed 1y. So I have y left and z to the power of 4. Let's go on to the next one. Minus x y square. So I'm going to remove minus. I'm going to take off 1x and I'm going to remove the whole of y. So I've removed minus and I've removed 1x, so that becomes x square and the whole of y is removed, z to the power of 4. Okay, so what is given you remove and write the remaining. So minus 5x, so I'm going to remove minus, I'm going to remove 5, I'm going to remove 1x and I'm going to remove the whole of y because it says y square here and 1z. So I'm going to write, I'm removing 1x, so I have 2 left. So x to the power of 2, the whole of y is going, and here there is 1z and there are 4, so that becomes 4 minus 1, which is 3. Okay, so I hope all of you understood that. You would do it carefully. Now there's one more part to this question. Also write the degree of the given algebraic expression. So let's count the powers. So I have 3 plus 2 is 5, 5 plus 4 is 9. So the degree of the given expression is 9. Which of the following expressions is a polynomial? Now you need to be careful here to find out which is a polynomial. You have to look at the powers. The power of every polynomial should be a whole number. Okay, so you have variables and like here we have x to the power of 3 and 3 is a whole number. So this is a polynomial. It should be a whole number, it should not be a fraction, and it should not be a variable. For example, it should be a whole number. Now suppose I write x to the power of 7. This 7 is a whole number. If I write x to the power of 1 by 2, here the power is a fraction. You cannot have something like this in a polynomial. And you cannot have 3 to the power of x or any number to the power of a variable. Okay, if it has to be a polynomial, it has to be a whole number. It cannot be a fraction, it cannot be a variable. So let's look out for that. Here x to the power of 3 is a whole number. So that is a polynomial. Let's go to the second part. Okay, so this is all right. X to the power of 4 is a whole number and x to the power of 2 is a whole number. Now this cannot be a polynomial because if I have to write this in a different way, now this is square root. So if I have to write, I will write it like this. It's become a fraction. That means this is not a polynomial. Okay, now here x to the power of 3 is okay, but when it comes to the denominator, it's not correct because it becomes negative. It cannot be negative. Now 8 by x to the power of 3, if I have to take x up to the numerator, I will write 8 x to the power of minus 3. When this is a denominator, when I take it up to become a numerator, this is how I should write. And I cannot have a negative number as my power. Remember, it has to be a whole number. So this is also not a polynomial. Okay, now here x to the power of 2 is correct, but here I have 3 to the power of x. I cannot have a variable as my power, so this is also not a polynomial. We'll go to the last one. This part is correct, but here this is wrong and I cannot have it like this, so this is also not a polynomial. So which of the following expressions is a polynomial? Only question 1. Only the first expression is a polynomial. Generate algebraic expressions for these. Okay, so algebraic expressions are expressions where you don't have words like we have added to the sum of. Instead, our letters and signs and symbols should give us this meaning. So let me write this. 15 added. So this is added to. So this should come second. Remember, 15 added to should come second. Added to what? The sum of x and y. So let me write that. I'll put it in brackets because it's the sum of x and y. Okay, so I have the sum of x and y and 15 is added to this plus 15. So can you see? I have written an algebraic expression where I have not written any words, but you can easily understand what I mean here. 15 has been added to the sum of x plus y. Second one, 23 is subtracted from. So again, 23 will come second. It's subtracted from. From what? The sum of 2m and 3y. So let me write the sum. 2m plus 3y. Remember, when we talk about sum, you're talking about addition. Now 23 is subtracted from this. That means minus 23. Next one. The product of A and B is added to their sum. Their sum means what? The sum of A and B. Okay, so product of A and B. What is the meaning of product? Multiplication. A into B. A into B is added to A plus B. So A plus B is the sum, and to this we add the product of A and B. A into B can be written as AB. A into B is written as AB. Next one, the sum of x and y is subtracted from. So that means again, sum of x and y should come first. Should come second. Okay, I'm sorry, it should come second. Is subtracted from their product. What is the product of x and y? X into y. So let's write that. X into y is xy. From this, we're going to subtract the sum of x and y. X plus y. Okay. Addition of x divided by y and y divided by x. This is easy. You simply add both. So x divided by y, and you add it to y divided by x. So this is how we write algebraic expressions. We'll stop with that for now, children. In our next video, we will continue with the remaining questions. Thank you, children.